Dear students, in this video, we are going to see 6.2 trigonometric intervals over 0, 2 pi. Okay. Now, you see here, we are going to find the value of the definite integrals by using that C is nothing but a unit circle, and we know the properties for that unit circle is Z is nothing but e to the power I theta. If Z equal to e to the power I theta, then we can say that 1 over Z is nothing but e to the power minus I theta. Okay. Now we substitute Z equal to e power I theta and 1 over Z is e power minus I theta here in sine theta and cosine theta. We know the rules for cosine theta and sine theta. Then here you substitute for e power I theta Z and for e power minus I theta 1 over Z, so that we will get these values for cosine theta and sine theta. Now, what is d theta? D theta is nothing but dz over iz. Okay. Now, you see the first example. Evaluate integral 0 to 2 pi 1 over 2 minus cosine theta d theta. Okay. So now here, what is the first point? First point, now here we have to change the variable from theta into z first. Okay. So 0 to 2 pi is nothing but here we are going to consider that is mod z is equal to 1, the unit circle. Okay. And here we know the value of cosine theta. What is the value of cosine theta? Z plus 1 over z divided by 2. Okay. Here we are going to substitute that one. Actually, it is here explained. So now, then what is d theta? D theta is nothing but dz over iz. So now what we are going to do? We are going to substitute the value of cosine theta and d theta. Then we will simplify. That is the first step. Then what we will get? We will get the given integrand in terms of z. Now you see here integral 0 to 2 pi 1 over 2 minus cosine theta d theta. Now we are going to convert from theta to z. So if we convert, so we will get this value. Substitute cosine theta d theta and simplify it. Okay, you will get, see, 2i outside, then it is a closed region, that is C, that is mod z equal to 1 unit circle. So 1 over z square minus 4z plus 1 dz. Okay. Now here we are going to get the help of Cauchy's residue theorem to evaluate this. Okay. So to apply the Cauchy's residue theorem, what we have to do, we have to find what is the function f of z, then what are the poles, and then what are the poles inside the condition, inside the unit circle. Suppose one pole is inside, then we have to find the residue for that pole. If another pole is not inside, no need to find the residue for that. Then how to find the integration is nothing but integral value is equal to 2 pi I multiply sum of the residues. Okay, so that is the Cauchy's residue theorem we have studied in the previous video. Okay, now here you see what is in the denominator, z squared minus 4z plus 1. So what we are going to do, you do factorization so that you can find the value of z. Okay, so now what is z? So now you do, see, this is the factorization. This is the first factor, this is the second factor. Okay, for this value, for this quadratic equation. Okay, so now we can say that z equal to 2 plus or minus root 3 are simple poles. Why? Because here degree is 1, here degree is 1, so that this is one pole, which is 2 plus root 3 is one pole, 2 minus root 3 is another pole. Both are simple poles. Okay, or we can say is pole of order 1. Okay, now what we have to check? Now you see here we have changed the function, changed the variable from theta to z first. Then we know that this is f of z. Okay, now we are going to apply the Cauchy's residue theorem. Okay, to find this integration value. For that, now we have calculated the poles. Now what we are going to check? We are going to check which is inside, which is outside. Now you see here. Now you see this. This is the unit circle. Okay. 2 minus root 3 is nothing but inside the unit circle. Now what is another pole? That is 2 plus root 3. 2 plus root 3 is approximately is nothing but 3.7. Okay. So it will be here, means outside. Outside the circle. It will be here. Okay. Outside the circle. So now what we are going to do, so now we found that which pole is inside. The 2 minus root 3 is a simple pole lies inside. So now we are going to find the residue for this. Okay, how to find the residue? Now you see here, residue of the function. This is the function from the simplification. Okay, so this is the simple pole, so that you know the rule how to find the residue, how to find the residue for the simple pole. Now limit is it going to this residue, and then see this function, see I write in the factorization form. Okay, now what is this, what is in the numerator, z minus this residue. Okay, this is the format, this is the rule, we know that how to find the residue. So now after the simplification, actually here we will cancel this one, then means we will cancel this term z minus 2 plus root 3, z minus 2 plus root 3. So what is remaining, 1 over z minus 2 minus root 3. So now here you substitute z 2 minus root 3, then you simplify it, you will get this value. Okay, so this is the residue. Okay, residue of the pole 2 minus root 3. Okay, now here fortunately only one residue inside the circle. So what we do now, to find the given integration value is equal to, this is already we have calculated, this integration is equal to 2i, you see here 2i multiply this value. So now, so this how we calculate, this value, that is 2 pi I multiply sum of the residues. So now that is what here, 2 pi I multiply sum of the residues, but here only one pole is inside, so this residue here. Okay, so now you multiply and simplify, this is the value of the given integration. Okay, this is the value of the given integration. Integral 0 to 2 pi 1 over 2 minus cosine theta d theta is nothing but, this is your answer, 2 pi over root 3. Okay, that's it. Now we will see the second question. Now you see, evaluate integral 0 to 2 pi d theta divided by 2 plus cosine theta. Now what we do, see similar method. Now take, what is z, what is 1 by z, what is dz, what is cosine theta. Now you substitute everything here, you do the simplification, then you will get one function. Okay, now you see here, see this is the given question, now this is the simplified form, actually this is the simplified form. Okay, so now after that what you do the factorization for the denominator value, then you will get two values for z, then you check what is inside, what is outside. Now see here both are simple poles. Okay, so now I take the one pole is alpha, one pole is beta. So which pole is inside? Simple pole lies inside, that is minus 2 plus root 3 inside the unit circle. Okay, always you consider the unit circle. Okay, so now this is outside, so no need to worry about that. So alpha is inside. So now we know that, find the residue of this alpha to the function f of z, then what is the value? 1 over 2 root 3, 1 over 2 root 3. So now what we do, by Cauchy's residue theorem, so now what is this value, what is this value is 2 pi I multiply sum of the residue, that is here 2 pi I sum of residues, that is 2 pi I multiply this. Okay, so you will get pi I over root 3. Okay, so this integration is pi I over root 3. So you multiply 2 pi I here, so multiply 2 pi I here, pi cancel, so 2 pi over root 3. Similar procedure, take z, take 1 by z, then what is dz, we know that, then what is sine theta, what is cosine theta, we know that, you substitute everything in the given, then you change the function from theta to z, then find poles, then which is inside, which is outside, then you find the residue, what are the poles inside, for that then apply the Cauchy's residue theorem, you will get, that's it. Now you see the example 3, find this integration value, similar method. Now you see here, what is cosine theta, you substitute, what is d theta, we know that, you substitute, what is our condition, that is unit circle, mod z equal to 1, that is no change. Now what you do, similar procedure, similarly you substitute everything here, the function, then change this from theta to z. Okay, now after that, see you will get this, if you do the factorization for the denominator, you will get this. So now we know that z equal to minus 1 over 2, z equal to minus 2, or two simple poles. Okay, so now what we do, which pole is inside, we have to check. So now we know that minus 1 by 2 is inside, minus 2 is outside. So which is inside, we have to find the residue. Okay, we know the procedure. So you find the residue, this is the residue. After that, what you do? What is the value of this integration? That is 2 pi I multiply 2 over 3. 2 pi I multiply 2 over 3. That is 4 pi I over 3. Then you multiply with 2i. Okay, so I cancel, 2 cancel. So this is the answer, 2 pi over 3. Okay. So now same procedure. You see, we know that what is z, what is 1 over z. Then you write sine theta and cosine theta in terms of z. Then write d theta in terms of z. Then you substitute everything. Then find the poles, then residues, then apply the Cauchy's residue theorem. Then you can write same procedure. Okay. Now, if we had wanted to find, you see here, you take this question. Example 3. This one. 0 to 2 pi d theta over 5 plus 4 cosine theta. Now, suppose I need the integration value from 0 to pi. See, that is in the note. Suppose I need 0 to pi. Okay, for the same integrand, suppose I need to find 0 to pi. What we have to do? Nothing. You see here, 0 to pi d theta by 4 plus 5 cosine theta is equal to 1 over 2 integral 0 to 2 pi d theta by 4 plus 5 cosine theta. Why? Because 0 to 2 pi is nothing but, if you take 0 to pi is nothing but 0 to 2 pi, you divide by 2. Okay, so that is here. See, already we know that the function cosine theta is even function, so that we can write this interval 0 to pi is nothing but half of this interval 0 to 2 pi. Okay, so if any question is asked in the interval 0 to pi, then you can do like this, 1 over 2 integral 0 to 2 pi, then you do the simplification. Okay, because we are using the unit circle. Now you see here, question number 4, evaluate this one, 0 to pi over 2 1 over 1 plus sine square t dt. Okay, now here instead of theta, here the function is given in t. Okay, so now similarly you write sine t is equal to e power it minus e power minus it by 2i. Then you write, what is z? We know that e power it. What is 1 over z? E power minus it. Then you substitute, which means you write sine t in terms of z, then substitute here. Okay, here the given question in the form of in the variable t. Now we are going to convert this into z. Okay, that is one point. Okay, another point is, now you see here 0 to pi over 2. Okay, this is what, 0 to 2 pi is complete circle. 0 to pi over 2 is nothing but 1 by 4th of this. That's why we are writing 1 over 4 integral 0 to 2 pi, the same. Okay, then what you are done here, the substitution you do here. Okay, then you simplify it, so you will get this value in the denominator. Okay, so now what is the degree here? 4. So you will get 4 poles, 4 simple poles. Okay, so now if you find the roots, so now 1 plus or minus root 2 and minus 1 plus or minus root 2. These are the 4 poles. Okay, what is inside, what is outside? Now you see the picture. Now you see, this is the unit circle. Okay, these 2 poles inside, these 2 poles outside. Okay, now here you see here the residues at the point. So what is inside? Root 2 minus 1 inside and minus root 2 plus 1 is inside, which means, see, this is inside, this is inside, that is here. Okay, both 2 poles inside, these 2 poles outside. So what are the poles inside? You can find the residue. Okay, so now after that, what you do, you add that residue. Actually this is the residue. If you find the residue for this, residue for this, by using the rule, then you will get this. Okay, fortunately we are getting the residue value same. Okay, so what you do, this residues you add, then multiply with 2 pi I, that is your answer. Okay, so now you see here, this is nothing but, the given question is nothing but integral this one. Okay, so now what is that? You multiply 2 pi I sum of the residues, that is your final answer. Okay, that's it. Thank you.